Welcome to an Algebra 1 sample question number 6 for the state exam. So here's number 6, a factoring question. It says, which factorization can be used to reveal the zeros of the function? And f of n is equal to negative 12n squared minus 11n plus 15. Factoring is a little difficult, so I do recommend you look up more videos or ask your teacher. But the way you would start it is rewrite the original. So I'm rewriting it there on the right-hand side. And then what I'm going to do is route the negative. So if you factor out a negative, 12n squared turns positive, 11n was turned also positive, but the 15 was turned negative. That's what it means to factor out. You're dividing each one by -1. Then you always multiply your first term and your last term. So your leading coefficient 12 with -15. If you multiply them, you get a -180. You're still looking for two numbers that multiply to -180 but add up to +11. Remember, this is assuming that you know how to factor. This is just a review. So you're looking for two numbers that add up to 11 and multiply to -180. I'm making my list on the lower left-hand side, and the list is only composed of the numbers that multiply to 180. So just the factors of 180. That's 1 times 180, 2 times 90, 3 times 60. And I would just do this with a calculator to make it a little faster. 4 times 45. We still have a lot more. 5 times 36, 6 times 30, 9 times 20. And I have a little bit more, but you can kind of see the winners there. 10 and 18, 12 and 15. So how would you multiply to a negative but add up to a positive? So our winners are 9 and 20. And to add to a positive number, but to multiply to a negative number, that must mean the smaller number, the 9, was negative, and the 20 was positive. I'm going to double check here. If you multiply them, you get -180. And if you were to add them, you get +11. So you have to be good with your rule of signs in terms of adding them, subtracting them, multiplying, dividing them. So I have our two winners there, -9 and +20. So what I'm going to do now is keep the first term, which was 12n squared. And then I'm going to keep the last term, which was -15. And I'm going to split up -11n into -9n and 20n. If you combine like terms, they do add up to 11n. Then from there, I'm going to do something called grouping. Grouping is when you take those four terms, you're going to GCF the first two, GCF the last two, and keep the sign in the middle. And if you guys can see, the negative stays there along for the ride. So the GCF of 12n squared and 9n is 3n. So you're dividing both by that. Sorry, I ran out of space there. And the GCF of 20n and 15 is 5, because 5 is what can divide into both of those. So you get 4n minus 3. Then from there, you can see that you have what I call twins. If you have those twins, that means you did them correctly. We're going to actually factor them out. So you get f of n is equal to that negative that we keep bringing along. And then the first one we would put is your 4n minus 3, because that's what you're factoring out. And if you divide everything by that, the only thing left are the 3n and the +5. And that is how you factor. Notice that is not on your list of answers. They actually made this one pretty tricky. So to figure it out, you just have to manipulate it just a tiny bit. So what we're going to do is we're going to multiply that negative with the first binomial only. So if you do that, it becomes -4n plus 3. And the second binomial, 3n plus 5, we left alone. That is how you factor. So looking at our final answer, you can see that it matches B perfectly. Just a friendly reminder that if you need help factoring, you can see the other videos on this channel, Mathematical Bandit.